Yo, what's up everybody? Welcome back to the channel, and today I'm just gonna be finishing off the neural network. And what we're gonna be doing is we're gonna be making a new class, or not that, making a new class, and calling it visualization. And if it isn't self-explanatory enough, we're going to be drawing all the neurons on the screen so you can see their values. And help with your debugging and tweaking everything, but first of all, make it a static class. And now what we're going to do is we need to make some imports, but not in the traditional way. We do have to make some traditional imports, so let's start off with that. System.collections.generic, and system.link, and system.drawing. And after that, the reason that we've used all of these is because well, we have to draw on the screen, and the first thing we have to do is we have to access the screen. And the way we do this is we have to get like the memory address. So we have to import a few things, because that's not really something that you do in C#. So we'll just import it from these DLLs. User 32. If you've never used DLL imports before, they give you access to native or unmanaged. They let you import unmanaged methods from, like, these ones specifically are from Windows. Windows gives you the user32.dll, but anyone could make something in C or like assembly or something, and then you could DLL import it into C# as long as you make it correctly. And then we also have to do release DC so that there's no memory leak. And the first thing we're going to do is make a public static void draw neurons, because, well, at least for now, it's really the only thing we're going to do, draw the neurons. And then to make this really easy on ourselves, we'll just take in the neuron list. So all we have to do is just put in our neurons, and that's it. And then we also have to make some things up here, such as we have to write some constant values. For example, we need to figure out how many neurons we want to draw on the screen maximum, and that's going to be 16, because it's just a nice number. And then the size will be 24 is probably a good size. That's just going to be the size of the neuron on the screen. They're going to be circles. And then what we gotta do is make the X and the Y on the screen that we want to draw them at. We don't want them to be at the top left, so we're not gonna make it 0. We're gonna make it give it like 2 spaces of what a neuron should be off the left of the screen. And then same for the top. So we'll just do that, set its value to the same thing, set Y to the same thing. And now we don't really need all of the bias or the error for the neuron, so we only need the value, so we could just store it in a list byte. And then we need to fill it up, so what we gotta do, we'll fill it up later. Actually, not really concerned about that right now. But we do gotta get the get the DC of the screen, which is what we made up here, and that'll just it's something that the graphics class takes in its constructor, and it'll let us draw on the screen if we get the DC of the screen. So we just do that by doing this. We can store it in a variable int ptr. Int ptr, not something that you really come across that often. It's mainly used for storing things like memory addresses. And then you just do int ptr.0 because it's asking for hwnt, which usually means window. But we're not really using a window, we're using the screen, so what we do is do int ptr.0. And then we're going to make some pens right here as well. And put them in a using statement so they get disposed automatically. And finally, another thing that we need to dispose of it would be the graphics. And as I said, you can get graphics from HDC or DC. And now keeps trying to indent it for me, but that's not really what you're supposed to do when you have something like this. And now the first thing we can do is fill a white rectangle so that we have space to draw it on. And since we're gonna make it the top left of the screen, and since your the width of your screen is larger than your height, we'll do something like this. So it'll just basically take up like the left rectangle of your screen. But if your screen isn't that big, you could adjust this. You could adjust all the sizes. These right here are the two sizes, and this is also gonna be the size. So you can adjust those accordingly. And now we actually have to go through and select all the neurons because we're gonna be drawing them. I'll just change it to layers. That makes a lot more sense. And now we're going to be filling the adjusted layers thing we made. I have to use x0 here because we already defined x up here. And what we're doing is we're going through every single layer, and that's going to give us a list of neurons. However, we don't, as I said earlier, we don't need the neurons. All we need is their activation. So we're specifically just selecting their activation. This, however, returns an IEnumerable, not a list. So we have to convert it to a list. And we're gonna put continue there because this is actually not what we're gonna want to do every time, because as I said earlier, we only are drawing 16 neurons maximum, and if there's a layer higher than 16, we have to check that. So if it's not less than 16, or if it is less than 16, then we will just add it, because then we're not gonna have to split them up a bit. We're not gonna have to squish it down to 16 neurons if it's already less than 16. But in the case that it is, we're gonna have to you could put an else statement here if it helps better understand it, but you don't really have to do that. the first thing I'm going to do is make a variable called split, and I'm going to make a uint16 because you're never going to have negative neurons, so you might as well make it unsigned 0364535. And what it's going to be is it's going to be the amount of neurons divided by the divided by 16, because that's how many neurons we're going to be drawing. And the reason I'm doing that is so that we can calculate the average of each group of neurons, and there's going to be 16 groups. Might as well make a byte array since we know there's going to be 16, or it would actually be whatever this variable is, which we have set to 16 right now. You could change it accordingly if you don't like 16. Make a counter, and also we'll make 2 more counters that are uints because we're going to need bigger numbers. I will just use to loop through the max layer length to draw, and that's going to be 16, and if it's not 16, it's probably not going to be higher than 255, because that would just be almost impossible to fit all on your screen. So unless you have a really really big screen, so yeah, we can just leave it as a byte. Now the split might be way above 255, so we're gonna have to use J to loop through the split, and then we're also gonna create a sum, because right now what we're doing is calculating the average of every neuron. That's in every. We've created 16 groups. Out of all the neurons, we've split them up into 16 groups, and now we're calculating the average of every group. So we need to create a sum, because as you calculate average, it's the sum divided by the total amount of things you add together. And then the counter is what we're going to be using to count how many things we've added together. So right now here, we're going to add the we don't even need to use the counter variable, we can just eliminate it. We'll just use J to count it. And now what we can do is we can say new neurons I, and I is going to go 0 through 16, so it's going to get every single one is equal to the byte sum dash split or sum dash J. Math is a little bit wrong, but basically what we're doing is now we've got the sum, and now what we have to do is actually calculate the average by the sum divided by the total amount of things the total amount of things we add together. Set the sum to 0 so that the next time it loops around it'll be set to 0 instead of what it was before. Same thing for J. And then we just increase I because we haven't done that yet. And as you can see, we're right now just storing it all in adjusted layers. We're not actually drawing them on the screen right now. So what we have to do is draw them on the screen. And now that we've created all the adjusted layers, there's a loop through every single layer. Then we'll look through every byte in the layer. And now we can actually draw the circle. As you can see, we I forgot to actually put a color here, so I'll do that now, but we've made the rectangle up here white. Now that means we have to use the pen, because we have to make it black now, or else if we use pen 0, then it just blend in. Now we set the X and the Y. The size, which we already defined that as well. But the thing we actually haven't done is increase the Y. So for every neuron that's in the layer, we're going to increase the Y, so it'll fall down vertically on our screen. But then for every layer, we're gonna have to set the Y back to the to what it was originally, so that it starts at the top again. And then we also have to increase the X for every layer, so that it goes to the right of the old layer, of the past layer. So instead of setting it, we're increasing it. That's the difference there. And finally, what we have to do, or not finally actually, we gotta do one thing after this, but what we have to do regardless is with the release DC function we made earlier, and then we just select the DC we had before, and this is just gonna prevent memory leaks. Now what we have to do is go up here and create a font, and you can really make this whatever you want, but the size is what has to, what matters. I'm just gonna make mine Verdana. I'm gonna make my font size, or I'm gonna make my font Verdana, that's the font name, and then the size what matters. You gotta make it, what we'll do is we'll make it neuron size divided by 3 actually. So we don't have to make it a constant, so we don't have to put a number in there, we could just use these constants only. I'll make it italic, because I think that's going to look better. And we actually have to use the font and draw the value of the neuron inside the neuron. There's a draw string function. So all we have to do is convert the value of the neuron to a string. Use the font we made, and then the brush is also going to be black. And then the X, and the only thing that we're doing for the Y is we're going to increase it slightly. We'll make it the neuron size divided by 4, so again we don't have to put any numbers anywhere. The only numbers that we used were right here, and I mean we could I didn't make those constant, but they're supposed to be. But we could also make 2 more constant variables, the height, the width and height is the order that we're going to do it in. And that's just so we can eliminate using these numbers. But it would have worked before either way. And yeah, there, now we have no numbers, everything's stored in constants really. Apart from anything that's like multiplied or zeros that are just used to initialize things. And then dividers as well. Now that we've finished this, what we could do is go into a neural network, and we left off by somewhere around here. We had if visualize, except it's empty. Now what we could do is say visualization.draw neurons, this.layers, because, as you remember, our layers are just a list of neurons, and the visualization, we just put that in so that we can make it easy for ourselves. Only need to call the function, and now we need to test it. I mean, a few good things happened, and that's just that it draws everything. But a few bad things happened as well. And that's just that I got a little ahead of myself when I was eliminating the counter variable. But basically what we have to do is add it back. And there we go, now everything works fine. As you can see, if I just run this one more time, as you can see, I'm not even looking at this right now. The last answer would have been 1, and I know that because it wasn't really confident, but as you can see, the highest number was 2, and there were 2 2s, but it's gonna always choose the first one. And as you can see, it did the same thing. 0 is the first one with the highest number, and that's why I said answer equals 0. And you can also see the inputs. They're mostly close to 255, and that's because that's accurate, because as you can see, when you have an image, it's mostly white space, but you can still see that some are going towards 0, so you can see that they are like 162 here, 133. Those are closer to the center, so obviously there's more black space in the center. And these are just averages, so if they were all written out, most of them would be 255 and some of them would be like 0. But they're averaged out, so it's kind of in between. And then another thing that you might notice is you can notice how the connections are working, and as you can see, most of the values in the hidden layer are 255 or 0. So that might say that you need to like, I'm not saying to actually do this, but maybe you should lower the weights even more or something. And now as you can see, there's like a 107 and 199, 142 and whatnot, and don't know if that's actually going to be any good, but you could test it, and as you can see, it's not good, but like, it is kind of cutting that out, where now there's some 180s, 41s, 164, and now you can kind of see that just by looking at having a visualization, you have a better idea of what to change. And if you wanted to, you could draw the connections as well, but I'm not going to, because I personally think it's just pretty, because if you look at the connections, the least you can do is just make them lighter or darker lines based on the strength of the connection. But then you'd have to calculate other things like the strength relative to the other ones. And then, even then, you wouldn't have an accurate number of the connections. There's no way that you could. There's so many connections that you can't draw. You can't write out the number of each connection. So it's just something that's pointless, in my opinion. But yeah, you can. And now, as you see that I set the number back to 10 there, is more 255 everything than it was before. There's nothing in the 100s and whatnot. But yeah, I mean, using this information, I'll do my best to make my neural network better. I suggest you all do the same. I don't actually recommend you copy mine. I recommend you use mine to get an idea of how one's laid out and how one should be, and then make yours better than mine. But regardless, I'm going to end the video here because I believe I've explained everything and the uses of this and how to do it. I mean, I'll explain why the counter variable is needed and why I thought it could be eliminated. And that's just because it's used to go through every single neuron. And because as you can see, it's never set to 0. It's used to go through every single neuron in one layer. It's never set to 0 unless it's a new layer. But the J is set to 0 for every group of 16, every 16 groups of neurons. So yeah, all you have to do to fix it is add the counter equals 0 up here, plus counter, and then you change this to counter. Apart from that, this is everything. I believe a lot of it is pretty easy to understand. But yeah, I'm gonna end the video here.